All right, um, intermediate algebra students, your next Khan Academy is Systems of Equations with Elimination Challenge. So these are a little bit more difficult, meaning you will notice as you look at these that the x's don't line up and cancel and the y's don't line up and cancel. So we have to do some manipulating. I kind of refer to it as the same thing as trying to find like a common denominator for either my x variables or a common denominator type thing for my y variables. In this one, I think I've elected that I'm going to find a common denominator for my x variables. You might agree that a common number between those would be 10. So in order to achieve this, I need one 10 to be a positive 10, and I need the other one to be a negative 10. So what I'm going to do is I'm going to multiply the top equation by, it's on there somewhere, I'm going to multiply the top equation by 5. What you'll notice when I do this, this will give me a negative 10 here, okay? Because this will be a negative 10, then I'm going to need this one down here to be a positive 10. So I'm going to multiply this one through by a negative 2, okay? Now, what you got to remember is this is just like distributing. I'm going to multiply this negative 5 by the 11. I'm going to multiply this 5 by the 9y. And I'm going to multiply this 5 by the negative 2x. Same thing goes down here. I'm going to multiply this negative 2 by the negative 34. I'm also going to multiply it by the positive 2y and by the negative 5x. When I do that, here are my two new equations that I get. I get negative 10x, positive 45y, positive 55 because I multiplied all three terms on the top by 5. And my bottom equation becomes positive 10x. This is now a negative 4y and a positive 68. So I can now, because I've been able to get my x's to line up, or as I add them together cancel, I just add these equations together. So 45y minus 4y is 41y, and 55 plus 68 is 123. Notice I'm adding these two equations together, adding them. Then I divide both sides by 41, and I get y equals 3. So my y coordinate is 3. Next, I need to solve for the x. So I always plug into the top equation when I do this. So I'm going to plug 3 in for y, and I'll show that right here. I've got negative 2x plus 9 times y, but the y is now a 3, equals 11. 9 times 3 is 27. We will subtract 27 from both sides, and we get negative 2x equals negative 16. We then divide by negative 2, and we get x equals 8. Okay. Now here's the deal. Along the way, it's easy to make a mistake. So there's an easy check everyone should do. You should take your x coordinate from here, you should take your y coordinate from here, and now plug into your bottom equation, this one, and just verify you've got it correct. So I call this doing my check. So here's my check. I plug in my x variable, I plug in my y variable, and I solve. Will this side on the left side end up equaling 34? So I get negative 40 plus 6, that equals 34. If they equal, then you know you did it correct. If they did not equal, and you did something wrong. Let's try it one more time. We'll go a little faster this time. Okay. This one here, I could line up my y's and multiply the top by 3 and the bottom one by 5. Or, a little simpler step, I could get my x's to cancel by just multiplying the bottom by negative 7. So, because I like simple, I'm going to multiply the bottom by negative 7. As I do that, the top equation will stay the same, but the bottom equation will become different as everything's multiplied by negative 7. Okay, the x's here will cancel. I've got 5y plus 21y is 26y. 31 plus 203 is 234. And then divide both sides by 26 and y equals 9. By the way, again, if you're wondering where did the 203 come from, it is simply the negative 7 times the negative 29. Two negatives equal a positive, and 29 times 7 is 203. So then, again, we now know that y equals 9, so I can plug that in. Second step, solve for x. So again, we take the original first equation, we plug in right here, we plug in that y equals 9, and we start solving. 5 times 9 is 45. Subtract 45 from both sides, we get 14x equals negative 14. Divide by 14, we get x equals negative 1, which goes right here. Not positive that's correct, so I'm now going to plug everything into the original bottom equation and do my check. And as I do that, I need to make sure this left side ends up equaling the negative 29. So let's see, we got 2 times negative 1 is negative 2, negative 3 times 9 is negative 27, negative 2 and negative 27 makes negative 29. The two of them are equal, so yes, my answer is correct. No, it took a little longer to get through this, but it was a little more difficult of a con. Have a great day. Bye-bye.